All right, a supermarket employee wants to construct an open top box from a 14 by 30 inch piece of cardboard. To do this, the employee plans to cut out squares of equal size from the four corners so that the four sides can be bent upwards, if you think about that. So it looks like, once we bend it up, it looks like the lid of a shoebox. What size should the squares be in order to create the box of the largest possible volume? So we're trying to maximize volume. Volume is length times width times height. So we have this initial piece, which is 14 inches, and this is 30 inches. So we're going to cut off these four little squares, and we're going to call them X because we don't know how big we want to make them. So if we fold, I'll call this X, 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 X. If we fold this up and we fold that up, according to these lines, then we've altered each of these two dimensions. So now this is not going to be 14 anymore. It's going to be 14 minus this X minus this X. So it's 14 minus 2X. The same thing is going to happen on this 30. It's no longer 30 all the way. It cuts off here and here, so we're losing X and X. So this is now going to be 30 minus 2X. So think about it like the shoebox. We have this little, I don't know if I can draw this, the shoebox lid, 3-dimension, kind of. We know this is X high. This is 30 minus 2X. And then this piece right here is 14 minus 2X. So we do know the volume now. So we have to figure out the length is now going to be, it doesn't really matter which one you choose, so 30 minus 2X. We have 14 minus 2X, and then the height is now X. So that's the volume. I want to distribute everything out. So we actually don't have another equation to start with, as opposed to the other two problems we did. We had perimeter, I believe, to start with, and then we went off that. This we don't. So I'm going to distribute. I'm going to multiply those two together. So 30 times 14 is going to be 420 minus 60x minus 28x plus 4x squared. We're going to multiply that all by x. So the volume is going to be, I'm just going to change the order around and combine like terms. So it's going to be 4x cubed. That's minus 88x squared plus 420x. Now I'm ready to take the derivative. So dv over dx is going to be equal to 12x squared minus, I think it's 176, let me double check. 176x plus 420. Now I want to set that equal to 0, and I want to solve. So let's see, can I divide 176 by 12? Let's see. Nope, it does not go into it evenly. So let's divide everything by, let's try 6. Nope. Oh, let's cut it in half. 6x squared minus 1, we said that was 88x plus 210. We could divide that by 2 again. I'm just trying to make this simple and a little bit quicker. Plus 105. All right, now to do this, we can either use the quadratic formula or we can factor. I think factoring might take us a little bit of time, so I'm going to use the quadratic formula. X equals 44 plus or minus the square root of 44 squared minus 4ac all over 6. So that's going to give me 44 plus or minus, I'm going to throw this in my calculator, 40 squared, 40. That's 676. And if I can take the square root of that, I think I recognize that, is 26. So this is 44 plus or minus 26 over 6. So my two answers, if I do 44 plus 26, and I divide that by 6, I get 11 2/3. If I do 44 minus 26, and I divide that by 6, I get 3. Now let's see about which one seems reasonable. Do you think that my x could be 11 2/3? Do you think if I took 14, I could subtract 2 of these measurements? No. So this one doesn't make sense. I know in the past we always said that if there was a negative one, that probably didn't make sense, but now you're going to get two positives and you have to reason through which one makes sense. So this is 3. That makes sense, because if I did 30 minus 6, that's okay to be 24. If I did 14 minus 6, that's okay to be 8. Those dimensions make sense. So let me just relook at the question. What size should the squares be in order to create? So x should equal 3 inches. That's how wide you should cut those squares.